Hello, this is Math 2231 coming to you from the College of DuPage for summer 2020, and this is the conclusion of the lecture entitled Product Rule, Quotient Rule, Trig, and such. When I left you, you were working on this problem and maybe you finished it. I hope you did, but if not, you know what to do. Let's see how you did. And here's the problem up here just to remind us of that. Well, we have to take the derivative, and so we take the derivative. This is a quotient, so it's denominator times derivative of the numerator minus numerator times the derivative of the denominator, all by the denominator whole squared. Now you have to do algebra with this because you're plugging in numbers and so on and so forth. So here's a useful algebra step. And here's another way to write that as well. You should verify that you come up with these things because I am going to be asking you to plug in numbers. And we're seeing what happens when you put 8 in. If you put 8 in and you do the calculation, you get negative 7 over 242. Again, much of our work will be done without calculators, so you would come up with something like that. And since that's negative, the volume is decreasing. Let's turn our attention to trig. You see, the tangent of x is the sine of x over the cosine of x. So it is a quotient. And we know the derivative of the sine, and we know the derivative of the cosine. So we now can calculate this derivative. So the derivative of the tangent is going to be the denominator times derivative of the numerator minus the numerator times derivative of the denominator. Notice the minus sign there. All divided by the denominator whole squared. If you do the calculation, you will get cosine squared x plus sine squared x, which is known to be 1. So that is 1 over the cosine squared x. No one calls it that, except for one of my math professors in college. But most people say, oh, the derivative of the tangent of x is the secant squared of x. Now, so we know this equation, we know this equation, we now know this equation. You should be able to do this based on your experience with that. And here you should recognize that the secant is the reciprocal of the cosine. It's 1 over the cosine. So you can do that. This is the popular way to write what that derivative is. And this is the reciprocal of the sine. This is 1 over the sine. And you can take the derivatives. Serious students will attempt these calculations, and all students should commit these results to memory. And now here's an example where you get to use those newly found derivatives. I don't expect you to have memorized them yet, but you should be able to do these problems. So differentiate each of the following. Realize I might be wanting you to plug in numbers, so you want to think about simplifying these as well. You know what to do. Let's see how you did. Okay, the first one is here, and I just take the derivative of the first and the derivative of the second and do a little bit of algebra, and I get this expression. For B, it's a little bit more involved because you have a product here, but it's the derivative of the first term minus, and then it's the derivative of this product. Now this minus is times the whole derivative of the product. So it is the derivative of the first times the second plus the first times the derivative of the second. And then we distribute that minus sign through. Here we have a product starting out. This is sine times cosine. And so this is going to be 5, it's the derivative of the first times the second, and the 5 is still times the first times the derivative of the second, and then the derivative of the cosecant is going to be negative cosecant x, cotangent x, and then you simplify this a bit, and that's what you get for that answer. Number D is a quotient, so it's going to be denominator times derivative of the numerator minus numerator times the derivative of the denominator. Now the derivative of the denominator, this minus is from the quotient rule, and what we had is a minus, but this is a minus, and so that is a plus, all over the denominator whole squared. And now if I start looking at this carefully, I say, oh, that can be simplified because that is minus 2 times sine squared t plus cosine squared t, which is going to be 1. And I think that's all the simplification that I can do there. And again, I usually will have you plugging in numbers. Life is a word problem, so let's look at a word problem. The amount of money in a bank account is given by this. You notice that there are fluctuations, recessions, and things because you've got these trig functions in there. During the first 10 years in which the account is open, when is the amount of money in the account increasing? This is going to be a calculator problem. You know what to do. Let's see how you did. And the problem is written up here again. Well, this is about the derivative, so we take the derivative, and when we take the derivative of that, we get simply this. Now we need to determine where in the first 10 years this will be positive because the rate of change is to be positive. So this is equivalent to asking where in the interval is the derivative positive. And since these are continuous functions, this is also continuous. So the intermediate value theorem that we studied tells us the derivative can only change if it first goes through 0. So we need to solve this equation. So we set the derivative equal to 0. And we end up with that this is when the tangent of t is equal to minus 1.5. Now we're solving this for radians, not degrees. And so these are the solutions that we get, and we'll end up taking the arctan of minus 1.5, and we get these solutions. Now, all of these solutions are not between 0 and 10, and you have to check to see which ones are. Here, the problem is still up here. So we're looking at the number line, and we see that this and this and this are 3 solutions that are less than 10. So there is the first point, there's the second point, and there's the third point, and we say, okay, what's going on here? Well, we do test values. The test value in this interval will be 1, 4, 7, and 9. And the question was, when is it increasing? And so it's increasing here because the derivative is positive, and here because the derivative is positive. We moved the ball a bit today. In closing, now more than ever, time is precious. Each day must count. Do the math. It will make you strong. And now, more than ever, take care of yourself and of each other. God bless y'all.